Welcome to week 3 problems. So let us start with a quote by Richard Feynman. Fall in love with some activity and do it. Nobody ever figures out what life is all about, and it doesn't matter. Explore the world. Nearly everything is really interesting if you go into it deeply enough. Work as hard as you can and as much as you want to on the things you like to do the best. Don't think about what you want to be, but what you want to do. Keep up some kind of minimum with other things so that society doesn't stop you from doing anything at all. Question number 1. The value of the integral 0 to 8 1 by x square plus 5 dx evaluated using Simpson's 1 by 3 rule is, given the step size is h is equal to 2. So we have to remember formulas like Simpson's 1 by 3 rule, 3 by 8 rule and trapezoidal rule. So I, according to Simpson's rule, is equal to h by 3 into y0 plus yn plus 4 times y1 plus y3 etc. plus 2 times y2, y4 etc. So given h is equal to 2, we have found y0, y1, y2, y3, y4 and then we substitute, we get the value of the integral as 0.567. So answer is 1. Question number 2. A canonical transformation small q to capital P capital Q is performed on a Hamiltonian h is equal to 1 by 2m p square plus 1 by 2 m omega square q square using a generating function f is equal to 1 by 2 m omega q square cos q. If q at 0 is 0, which of the following graphs shows the dependence of q with t? So it is very clear that the Hamiltonian is of a simple harmonic motion. So q can be supposed as a sine omega t to get the solution easily. Now the generating function is given. So refer my notes on generating functions in canonical transformations. There is a relation that p is equal to dou f by dou q. So small p is equal to m omega q cot q. Again, using Hamilton's equation of motion, p dot is equal to minus dou h by dou q. So p dot is equal to minus m omega square q. So small p equal to integral p dt equal to m omega cube a cos omega t. So substituting or equating 1 and 2, we get that m omega cube cot q is equal to m omega cube a cot omega t. Solving, we get q is proportional to t and q is 0 at t is equal to 0. So it is a straight line passing through origin and it is linearly varying with t. So answer is 4. Question number 3. A distant source emitting radiation of frequency omega moves with a velocity 4c by 5 in a certain direction with respect to the receiver. So if the upper cutoff frequency is 3 omega by 2, find the angle theta so that the receiver detects the signal. So this is a simple Doppler shift problem where we use the approximation relation f prime is equal to f plus 1 plus u by c cos theta. Substituting the values, 3 by 2 omega is equal to omega into 1 plus 4 by 5 cos theta. Cos theta is equal to 5 by 8 or cos theta is equal to 2.5 by 4. So it is very close to the answer cos inverse 3 by 4. So hence the answer is B. Question number 4. The Lagrangian of a particle moving in a plane is given in Cartesian coordinates as L is equal to x dot y dot minus x square minus y square. In polar coordinates, the expression for the canonical momentum PR is, so what we have to do is that we have to change the Lagrangian from xy, that is Cartesian coordinate, to spherical polar coordinate. We know that x is equal to r cos theta, y is equal to r sin theta. So x dot and y dot, we find it out, and we multiply x dot and y dot, and then substitute x square plus y square is equal to r square. So we will get L is equal to r dot square cos theta sin theta plus r dot cos square theta minus sin square theta theta dot minus r square sin theta cos theta theta dot square minus r square. Again, using Lagrange's equation of motion, we know that PR is equal to dou L by dou r dot. So PR equal to 2 r dot cos theta sin theta plus r dot cos square theta minus sin square theta. So the obviously answer is r dot sin 2 theta plus r dot cos 2 theta using the trigonometric relation. Now question number 5. The heat capacity of a refrigerator is 4.2 kilojoule per Kelvin. The minimum work done to lower the internal temperature from 18 degrees Celsius to 70 degrees Celsius if the outside temperature is 27 degrees Celsius is. So it is a very simple problem. First of all, you have to understand that Q2 is the amount of heat to be removed to sink. So it comes as a formula mcdt. So 4.2 kilojoules should be removed. And using the standard relation Q1 by Q2 equal to T1 by T2, we find Q1 is equal to 300 by 291 into 4.2. So what is work done is W is equal to Q1 minus Q2. Substituting the values, we get the work done is equal to 0.13 kilojoules. So approximately it is 0.14 kilojoules. The answer is 4. Now here we have a straightforward question. Question number 6. For a system of independent, non-interacting, one-dimensional harmonic oscillator, the value of free energy per oscillation in the limit t tending to 0. So this is a 0 point energy concept. So answer is h nu by 2 or h cut omega by 2. It's a straightforward question. Question number 7. The partition function of a system of n Ising spins is equal to z equal to lambda 1 raised to n plus lambda 2 raised to n, where lambda 1 and lambda 2 are functions of temperature but are independent of n. If lambda 1 greater than lambda 2, the free spin energy per spin in limit n tending to infinity is. So you can refer to my lecture notes where we deal with the expressions of thermodynamic functions in terms of partition function. So when n tends to infinity, f is equal to minus kt log z. Z means partition function. We substitute the partition function value as lambda 1 raised to n plus lambda 2 raised to n. And taking lambda 1 outside, since lambda 1 is greater than lambda 2, we can approximate f is equal to minus kt log lambda 1 raised to n. So it is equal to minus kt n log lambda 1. So free energy per spin is equal to f by n. So it is equal to minus kt log lambda 1. So answer is 4. Now question number 8 is a question related to shift resistors. In the schematic figure below, the initial value of a 4-bit shift resistor A and B are 1011 and 0010 respectively. The values of shift resistor A and shift resistor B after the pulse T2 are respectively. So from the diagram it is clear that T1 and T2 clock pulse are only deciding the output of the shift resistor A and B. Since shift is equal to 0 for the clock pulse, T is equal to T0. So the shift resistor A, the output of the shift resistor of A is fed back to the input. So when the time pulse T1 happens, the output, that is 1, in the shift resistor A is fed back to the input of the shift resistor A. So 1011 becomes 1101. Again, when another clock pulse comes, that is T2, again that 1 shifts to the input, getting the result 1110. So the answers can be 1 or 4. Now, considering shift resistor B, the output of A is fed back to the input of B. So in the T1 clock pulse, the output of A, that is 1, is fed back to 0, 0, 1, 0. So it becomes 1, 0, 0, 1. Again in T2, the 1 from the output of A is fed back to the input. So resulting in 1, 1, 0, 0, which is the final output. So the answer is 4. Now question number 9. If the parameter y and x are related by y is equal to log x, then the circuit that can be used to produce an output voltage V0 varying linearly with x is, so there are 4 circuits given, and the circuit that 1 and 4 contains capacitor. So it should be rather a differentiator or an integrator. So the choice is left to 2 and 4. Now what we are trying to do is that we use the principle of virtual ground, that is I1 equal to I2. Now let us consider the choice number C or 3. We can see that I1 is a current from a diode. So I1 is equal to I0 exponential QV by KT minus 1. If we neglect 1, considering that the voltage is high, so I equal to I0 exponential QY by KT, and I2 is the feedback current, that is equal to minus V0 by R. Equating, we find that I0 exponential Qy by KT is equal to minus V0 R. I0 is a constant, Q is a constant, K is a constant, T is a constant, R is a constant, and since Y is equal to log X, we get that V0 is equal to proportional to X. So the answer is C, and if you are interested, you can check the answer of 2 also. And the answer of 2 is that output voltage is log of log x, because y is log x and this is a logarithmic amplifier, and hence the output voltage of choice number 2 is log of log x. So in this case, choice 3 is the answer. Now coming to the final problem of V3. This is a question from variational method in quantum mechanics 2. The question goes like this. The ground state voltage energy of a particle in a potential V g mod of x, estimated using the trial wave function psi equal to root of c by a raised to 5 a square minus x square, where x is less than a, mod a. So here we have to know some basic rules while doing variational method. One of the important formulas to remember is psi should be 1. So using that we can find the normalization constant. Again, to find energy, we have to find psi h psi. If it is not normalized, then remember that the energy eigenvalue is psi h psi by psi psi. Now to find the minimum energy, we have to find the condition where h is minimum using the condition dou h by dou a is equal to 0. So these are the conditions which will be used to get the answer. So I have done the complete procedure. You can look into each steps and you can find that psi you will get an yield and answer 16c by 15. So please spend some time in looking to the derivation of psi equal to 16c by 15. And again I have to find energy. So E is equal to psi h psi. So substituting h is equal to minus h cut square 2m dou square by dou x square plus v. I have splitted this solution into two. One part I will be finding psi dou square by dou x square psi, and then another part I will find psi v psi. So in the first part I get an answer psi dou square by dou x square psi as minus 8c by 3a square. And the second answer is quite tricky because you have to remember that the potential V is equal to G modulus of X. So you have to consider that X is always positive. So a slight rearrangement of the integration, that is, you should not integrate from minus a to plus a. If you integrate from minus a to plus a, this integration vanishes. So it is clearly mentioned that the X should be modulus of X. So I have changed the integration from minus a to plus a to 0 to a, and I found the integration answer as 3GA by 3. So these values in equation number 1. So I get H is equal to 8 H cut square C by 6 MA square plus CGA by 3. Now let us apply the last condition, that is dou H by dou E is equal to 0 when H is H minimum. From solving that, I get A cube is equal to 8 H cut square by mg. So you can spend few minutes in solving this integration, and A minimum we will get it as 2 into H cut square by mg raised to 1 by 3. Substituting this value in H, I get H minimum equal to 8 H cut square C by 6 MA square into 1 by 4 into mg by H cut square raised to 2 by 3 plus Cg by 3 into 2 H cut square by mg raised to 1 by 3. Substituting and rearranging, I get the answer as C H cut square G square by m raised to 1 by 3. Now remember that this function is not normalized, so you have to divide by normalization factor 16c by 15, getting the answer as 15 by 16 H cut square G square by m raised to 1 by 3. So here comes the end of week 3 problems. So let us end with a motivational. I know that the questions are getting more tougher, but remember that you never know how strong you are until being strong is the only option you have left. Thank you. See you next week.